Here we have the electrochemical series, and this series is telling us the tendency for a cation to be discharged to the cathode and the tendency for anions to be discharged at the anode. So most often what we will see that it's going to be hydrogen that's discharged, and the reason why he's discharged is because he is very low in this series. Only thing lower than hydrogen is copper, mercury, and silver. So here we are going to be identifying the positive and the negative ions in different compounds. Okay, so sodium chloride, we already have the negative, so the positive is going to be the metal. Yes, the metal, which is your sodium. Good. Now here we have, so in each compound, remember you're going to have a positive charge and you're going to have a negative charge. Okay, the positive charge is normally a metal, or it could be a polyatomic ion ammonia. All right, but in most cases you're going to have a metal and you're going to have a non-metal. The metal is going to be a positive, it's going to give you a positive ions because metals lose electrons to become more positively charged, whereas the non-metals, they gain electrons to become more negatively charged. So here we have lead and oxygen. So lead is your positive ion, good job. And then you have oxygen is your negative ion. What about magnesium and chloride? Yes, magnesium is a positive ion, whereas the chlorine is your negative ion. Next, zinc and bromine. Zinc forms your positive ion, all right? And then bromine forms your negative ion, okay? Keeping in mind that zinc's charge is going to be positive too. So how do we decide which ions are going to be discharged? How do we decide which ions are going to be discharged in a molten solution, in a molten substance, an aqueous solution, a dilute solution, and a concentrated solution? Okay, so this chart is very important, and it's very important, and you should definitely memorize this chart as it will help you. So in a molten substance, remember you only have, it's only the ions within the compound. Okay, so this is why you're going to have the positive, whatever positive ion is present, that's what's going to be discharged at the cathode. And whatever negative ion is present, that's what's going to be discharged at the anode in a molten substance. Now, in an aqueous solution, remember, when you add water, you also have hydrogen and you also have hydroxide present in the solution. So this is going to impact which ions are discharged in aqueous, dilute, and concentrated solutions. However, it will not impact molten substances because molten substances have just been melted. It has no water added. So in aqueous solution, you are going to be using of course, your electrochemical series, okay? And I would have summarized this all for you. So an aqueous solution at the cathode is going to be the H plus. It's going to always be H plus unless you have copper or silver present. If you don't have copper or silver present, it's going to be H plus. At the anode, if it's an aqueous solution, is going to be hydroxide unless a halide is present. We know that the halides are found in group 7. In dilute solution, the ions discharged at the cathode is going to be H plus, again, unless copper and silver are present. At the anode, you're going to have, of course, OH negative because you have more water present. Remember, a dilute substance, you would have had to add a lot of water to that substance, right? So because you have more water, you're going to have OH negative is going to be discharged. In a concentrated solution, all right, remember it's concentrated with a particular negative ion. So at the cathode, you're going to have H plus unless, of course, copper or silver is present. However, because it's a concentrated solution, you're not going to have OH negative because remember, concentrated solutions, you have more of the negative ion. Okay, so what's going to happen is you're going to have the ion. So whatever ion is in higher concentration, that's the ion that's going to be discharged. Okay, you could have bromine, you could have chlorine, okay, you could have iodine. Whichever negative ion is in higher concentration, that's the one that's going to be discharged at the anode for concentrated solution. So we have some examples here, we're going to try them. So the name of the electrolyte is molten sodium chloride. So what's going to be the ion discharge at the cathode? Sodium, very good, because we know that there's no water added, so it's just the ions in the electrolyte. So you have sodium in the electrolyte as your positive ion, and then you have your chlorine as your negative ion. Very good. Remember, your metal gives you your positive ion, and your non-metal gives you your negative ion. Metals lose electron, becomes more positive charge, more positively charged, and non-metals, they gain electron and they become more negative. Good job. Next is the aqueous. Now, aqueous dilute concentrate. Remember, now we have water being added, so you also have H plus and OH negative in addition to your ions in your electrolyte. So the ion discharge at the cathode is going to be H plus. Okay, remember we use the electrochemical series, a little chart that we use the electrochemical series, and remember I summarized it for you in the slide before this. Okay, so you're going to have H plus, all right, as your at your cathode, whereas in your anode you're going to have, what do you think you're going to have? You're going to have Cl negative. Okay, you're going to have chlorine. All right, now you're going to have chlorine because the option was either chlorine or OH negative. Okay, and at your anode you're going to have the chlorine discharge here. Okay, now here we have a dilute solution, and here again you're gonna have H plus being discharged unless you have copper at your cathode. If you have water being added, all right, it's going to be H plus discharge unless you have copper or silver. Now at the anode, we have what's going to be discharged at the anode for dilute solution. Remember, dilute means you have more of the water. So you're going to have what ion is going to be discharged? OH negative. Good job. Concentrated solution at the cathode, you should automatically say H plus. All right, concentrated sodium chloride solution, you're going to have H plus, and then you're going to have the ions at the anode is going to be Cl negative because you have a higher chlorine concentration. Okay, that's it. That's it. So now we're going to look at the electrolysis of molten sodium bromine, and we are going to go right ahead and we are going to identify these different parts. So now let's go. Ions present. What are the ions present? Sodium and bromine. All right. And why? Why is it just only sodium and bromine? Because the substance is molten, which means that it would have been melted. And being melted means that melting a substance means that we did not add any water. Okay, so this is why you only have these two ions. Now, which ions are discharged at the anode? We use our chart, all right? And our chart here is going to tell us what ions are going to be discharged. So we have at the anode, we have the negative ion, and at the cathode, we have the positive ion. So at the anode, we have the negative ion, which is bromine, all right? And because the bromine is going to be attracted to the anode, okay? The negative charge of that ion is going to be attracted to that anode. And the cathode is going to sodium positive ions are going to be attracted to that cathode. Now the cathode electron equation. So you're going to have sodium. All right, Na plus sodium ion is going to become an atom. So Na plus E, you're just repeating, you see this where you have this plus here, you're just repeating it back. I'm putting it right back here. And then you're going to put electron, okay? Produces arrow sodium atom. So now the reason why we have the plus E here is because, listen, remember we have to balance the equation. We have to balance the equations with the electrons, okay? So electron equation means you have to balance the equation with the electrons. So remember the sodium ion has one less electrons because it would have lost it. Metals lose electrons, right? So it would have lost its one electron to form a positive ion, okay? So here you have one less electron. So I'm just going to say plus electron, okay, to produce sodium, because the sodium on the right hand side has an extra electron in his valence electron. Remember, because it's in group 1, so it has one electron in its valence shell. All right. So adding the electron here just balance off the equation. Okay. Next you have the anode, and the anode equation is your Br negative minus electron, right? Because remember, you have Br negative, you're just going to repeat, just repeating the sign with the electron is going to give you it, it's going to balance it for you with the electron. So minus the electron gives you Br2. Now remember Br2 because bromine is diatomic. Now, there are two bromines here, only one bromine here. The equation is not balanced, so we need to balance the equation. So I'm going to put 2 in the front of bromine to balance it. And then if I have 2 bromine negative here, I need to also put the 2 in front of the electron to balance it. And now it's balanced. The electrode where oxidation happens is the anode, and the electrode where reduction happens is the cathode. Good job. So now I'm going to be asked to predict the ions that are going to be present for the dilute sodium chloride. The ions present are, let's go guys, you got this. The ions present are sodium, bromine, hydrogen, and OH negative. The ions at the anode is bromine and hydroxide, okay? All of the negative ions there, ions at the cathode, all the positive ions are going to be attracted to that cathode. Now, which is going to be discharged at the cathode and which is going to be discharged at the anode? That's going to be the equation that you show. So dilute, we have H plus, unless copper or silver present, we don't have none of those, so we know it's H plus. So H plus E gives you H2. Now, what is wrong here? We have 2 hydrogens on the right, but we only have 1 hydrogen on the left. So what do? We need to balance the equation. Yeah, so we put the 2 in front of hydrogen and the 2 in front of the electrons. Good job. Now, what about the anode reaction? So anode reaction, OH negative because you have more water. So this is your anode equation. OH negative becoming water and oxygen. OH negative producing H2O plus oxygen. That is your anode equation. Now the electrode where oxidation happens is the anode, where reduction happens is the cathode. Good job. So here we have the electrolysis of concentrated sodium chloride, which is called brine. Okay. Now we're going to predict the ions present. The ions at the anode, at the cathode half reaction, anode half reaction, the electrode where oxidation happened, and the electrode where reduction happened. So what are the ions present now? Sodium, bromine, H plus, and OH negative. What about the ions at the anode? Okay, that's going to be all of the negative ones, right? So bromine and hydroxide at the cathode, all of the positive ones. Now let's get the cathode half reaction. By now you should know that it's going to be H plus because we don't have copper or silver present. All right, so you have H plus electrons give you H2, and we know we have to balance it. We have to balance this equation. So hence, we have the 2 in the front of hydrogen and the 2 in front of the electron. The anode half reaction is, the anode half reaction? All right, we know that it's concentrated, so you have more bromine, which is what we just looked at. So it's going to be bromine minus 2 electrons give us Br2, okay? And notice we balanced it, all right? We balanced it right away. Right, so the electrode where oxidation happens is the anode, and the electrode where reduction happens is the cathode. Good job. During brine, we had different things being produced. Okay, at the anode, we had chlorine. Chlorine was produced. At the cathode, what did we have produced? Hydrogen, yes. Hydrogen was produced. And then which ions were not used? Sodium was not used, and the hydroxide was not used. Okay? So as a result, the sodium and the hydroxide are going to combine together to form sodium hydroxide. So uses of brine would be the uses of the chlorine which is produced, and we know uses of chlorine would be bleach, hydrochloric acid, and then we have, remember, sodium hydroxide because we did not use sodium or hydroxide, so they combine together to give us sodium hydroxide. And we have paper, the use of it is paper, soap, and we also had the hydrogen being produced at the cathode. And uses of hydrogen would be the margarine as well as the ammonia. Okay, these are the uses of brine, which you might see, might ask you this, so make sure you could give some.